All right, here's another problem where you're going from moles this time to atoms. As always, we're going to start by writing down what's given and then go from there. 2.3 moles would go first, and we're going to write the whole label, moles of sodium, times, since moles is in the numerator here, it's got to be, that unit's got to be in the denominator in our conversion factor to cancel. So I know that 1 mole of anything is equal to Avogadro's number of atoms of whatever element or compound you're speaking about. So what would go here, since we're dealing with atoms, Avogadro's number. So we write that on the top, all right? And we're left with atoms, all right? Since in this case there's only a 1 on the bottom, there's nothing that we have to, no other number we have to divide by, so we just have to multiply across. If you have a TI-30XA or some other scientific calculator that's similar, you can use an EE button. Just make sure you know how your calculator operates. If you don't have an EE button or you prefer to use a Y to the X, that's your prerogative, but just make sure you know how to put in numbers into your calculator that are in scientific notation. This one is simple to do. I like to put that number in first. So I'm going to do 6.02 EE 23 and hit equals just to lock it in, times 2.3. And I'd recommend always do it several times just to make sure you didn't hit something that you didn't mean to hit. All right, my calculator gives me this expression, all right? But that's not the way you want to write it, okay? That's a calculator way of responding, right? So when you actually write that number, you can round up a little bit. So I'm gonna say 1.38 times 10 to the 24th. And we're looking for atoms of sodium, Na. All right? So my final answer is 1.38 or 1.9 times 10 to the 24th atoms of sodium.